There it is. Alrighty, good evening, everybody. Welcome to another Zero to Hero session. Tonight we have Nick, and he's going to be doing some stuff with PF Sense Firewall. So without further ado, Nick, go ahead and take it away.
Thank you, David. So yeah, as David said, we're going to be discussing primarily the use of firewalls and also network segmentation. We are going to start with a very short 2-slide presentation just to explain what each of those things means. So if you will excuse me a moment. So VLANs and firewalls. VLAN, or a virtual local area network, is basically a way we can separate a network out logically without having to rely on separate physical connections. And this is very useful if you imagine an enterprise, such as the one depicted in the photo. They might have different business groups, IT, HR, and sales in this case, and they're going to have different needs, different access privileges, different data that they want stored securely and away from the other departments. There's absolutely no reason that the sales team needs to be able to see very sensitive HR information. And likewise, IT might not want their resources being used by HR or sales, and vice versa. VLANs allow us to separate a network, even if they're all set up, together, because of course we want this, but we don't want to buy like 3 different switches, 3 different routers, 3 different drop points, 3 of everything, just to make sure that it's good throughout the building. And we also don't want to just specifically cordon off sections of the building solely and unchangeably to a single department, because what if that department grows or shrinks, or the business grows or shrinks, and it becomes a massive problem. So VLANs provide us with this massive flexibility to segment our network into its own essentially mini networks attached to the network. Now, it also allows us to isolate traffic within networks, which is important for things like broadcasting, because essentially on a network, especially a local area network, there'll be certain times in which a computer wants to just ask every other computer in the network. One example of this would be an ARP packet. You might have heard us talk in previous seminars about a MAC address. This is basically the hardware identifier of anything on a network. A device might come into possession of some data heading for MAC address, but it has no idea where to actually send that data. And so it'll send out an ARP request, basically asking everyone on the network, are you this MAC address? And if they aren't, they stay silent. If they are, they'll respond. Now, this is pretty simple on small scales with separated, isolated networks. But if you try and expand it, put it to scale, obviously that would break down. It also allows us to enhance the efficiency and the security of our network by allowing us to do some tricky things with the firewall rules that we're going to be seeing later. Now, in this lab that we're going to do immediately following this presentation, we're going to have 3 different machines that we're focused on. One is a web server that we want the public to be able to access from anywhere, that will have some sort of system to query a database server that, we want the web server to be able to communicate with the database server, but we don't want any random Joe to be able to communicate with it. So this web server is going to need to communicate with a private server, and then we're also going to want a workstation, because of course we want to do some work. We want to, in our case, we want to interact with the PF Sense web configurator, so we don't have to do it all through terminal. But essentially allows us to do some design our network and architect it in a much more secure manner. And now we're going to be using PF Sense to manage our VLANs. PF Sense is a very robust piece of software. It's primarily thrown on level, you can throw it on a lot of things, from switches to routers, to essentially actually facilitate the designation of VLANs and how they work. Now, I was talking a bit about firewalls, and for an explanation on what those are, they're essentially a security barrier for any sort of packet entering in anywhere. Now, there's different types of firewalls. Some of these, like the ones we're going to configure, are going to be at the network level. They're going to be, deciding rules based off of one VLAN into another, from outside the network into our network, what a VLAN can do theoretically to itself. But there are other types of VLANs. There's firewalls. There's application level firewalls in which an application might only accept this data, that data, very specific to like a web application. There's host firewalls. You might have seen us play around with those in a few other seminars. These would be things like IP tables, UFW, which is uncomplicated firewall. And the point of those is basically just at the host level, what do we define as what we want to be receiving, what we want to be sending? It's very fine-grained control for them. Now they can either be software or hardware. There are hardware network firewalls. Cisco makes quite a bit of money selling some very expensive firewalls because they let you do some really nice things, especially along with what's known as intrusion detection and prevention systems, which basically allow you to identify anomalous activity and respond to it. But they can also be software, which is what we're going to be using with pfSense. You can throw pfSense on some dummy switch that has no complicated, circuitry there. Only acts on layer 2 of the networking model. You can connect it with a computer to maybe some small PC to facilitate the actual running of the switch. Would you have any questions whatsoever on either of those two things?
We are good, David. Nick, you can continue.
All right, perfect. In that case, we'll just jump straight into the lab here. So we're going to be having 4 machines. First is this pfSense machine. Right now, it's on it's going to look slightly different to this, but it's basically on its own little, it's on its own box, and we can interact with it from this box, but we don't want to because that is prone to error. It can be hard to track. It can be, hard to, excuse me, hard to actually do and perform. A lot of memorization. It's sort of like Windows versus the terminal. Once you get proficient with it, or you're trying to do automation, the terminal is fantastic. But I mean, if you're dealing with this, dealing with a software maybe once a day, it might be hard to actually take the time to learn that terminal. So we're just going to be using a web portal that it actually supplies for itself. Past that, we have this database. It's going to be our private database. It's running what's known as MariaDB. This is a relational database software. Oh, yes. Sorry, Shreyas, do you not...
You should be able to. In your case, what you'll most likely do, especially if you already have an instance running, is you want to go back to the main dashboard. You'll press stop. It'll kill all of the machines that you currently have. And then when you press start, it'll spawn new ones based on this lecture. Hopefully that makes sense.
Actually, I haven't started any machines currently, but it is showing 4 of the machines.
What are they called?
Those are DNS YP, DNS Web, DNS Web 2, and DNS Attacker. These are 4. And none are active right now. Like I have not started yet.
Let me see. Give me one sec.
Oh, that's not a problem. We can wait for that. Just to give you a quick rundown on just the other boxes on the network that you're going to be working with, Shreyas.
Yeah.
We have this Ubuntu machine for our workstation, and then we have a web server running on Debian.
Debian, okay.
Yeah, so you're gonna want to give me one sec. Let me find what that dashboard was real quick. So you're gonna want to go.
I'm in the server view. In server view, I'm unable to see.
Yeah, you don't want the server view. You want to go back to this IP address. You're gonna want to go back here and log in again. And then after you do that, you'll have the option to press stop. It'll wipe out the current setup because that's the one from the last session. And then when you press start, it'll spawn all the ones for this session.
266. Okay, I'm at the control panel. Should I directly stop it then?
Yes.
Okay,
So press stop.
19 seconds remaining.
Yep.
So for every session, there are different environments set up on Proxmox.
Yeah,
Or
at some point, because we were busy developing everything kind of as we're going for the semester. At some point, I'm gonna try and have a setup where it'll just have all of them that you'll need if you wanted to go back and do them.
Yeah, should I start the environment again then?
Yes.
Okay, okay. Okay, sorry for the trouble, Nicholas.
Oh, no, it's all good. No,
You can
I
start
get it.
anytime.
Yeah.
I mean, hey, you're the one here, so not a problem.
Nick, just as a heads up, if you could, you see where it says console on the top right? If you could just pop it out whenever you use it. So you see the console on the top right?
Yeah.
That would help. Yeah, that would be great. Alrighty. Cool. Shreyas, are we ready to go? At least in terms of, I think it's set up for you. I see the machine's ready. So I think we should be good to continue, Nick.
Yeah, sure.
All right, perfect. So, as we said, we want to come up with a network architecture we have our web server is accessible by the public. It communicates with our database, which is not accessible to the public. And we have a workstation that can do pretty much everything. We can be pretty permissive with the workstations just for the purpose of, of the demonstration here. So in order to get started here, you're going to go to your little INSTPF sense here. You're going to click on it and wait for it to get started. It's going to give you a slightly different page than this. You're not going to see the public facing server, private facing service workstations here. I set those up like expecting it to take a short amount of time to remove them, but fortunately, I don't think I gave this machine enough RAM, so it's a little bit slow, but it's not really anything to worry about. The main point of contention is with this LAN VT-net v4, you see this 192.168.1.1. That's going to be the IP address that pfSense is going to be serving its web configuration portal on. So if we, for example, go back to our workstation, WORK work. Sorry. Let me run down. Pretty much everything has the same username password for everything.
So for pfSense, it will be pfSense only. Like I got 4 machines, SEM, pfSense, database, workstation, and Web2.
Yeah. So pfSense, the credentials I believe are admin/admin. So admin is username, and then when it asks for password, you type in admin. The database is database.
Mm-hmm. Yeah.
The workstation is work, and the web server is web.
Okay.
Now, all these also have root accounts. They share the same password. It's just in order to access that admin elevated credentialed root account, we'll have to go into it using typically su space or just invoking sudo, sort of. But yeah. So are you able to get into that pfSense machine and have it boot up to this primary screen here?
Okay. Yeah, I got this screen. Same screen.
Perfect. All right. And you see that 192.168.1.1 on the LAN interface?
One moment. I'm checking. Yeah, one. LAN interface. Yeah, I got it. Yep.
Perfect. All right. And just for a bit of context, you'll see LAN, local area network, WAN, wide area network.
Yeah.
Essentially, the wide area network is the facing out to the internet. The local area network is facing in towards us. You can think about this as just the local area network is local to you. The wide area network stretches over wide distances.
Yes.
All right, so in order to access that web configuration, we just go to the workstation. We log in, work. We open up your favorite browser, well, or at least the one that's here, Firefox, which is my favorite browser. And you're just going to go to that IP address, 192.168.1.1. And after a while, it'll bring us to the web configuration portal. It's going to ask us to sign in. When you first set up a pfSense box, it typically has the default credentials admin and pfSense for the password. But here we've just changed it to admin because we love the deeply secure practice of duplicate using your username as a password, but I'm not going to worry about that. Just make sure not to do that in a competition. So we're going to type admin, sign in. Don't save, I can remember that, I hope. And we're going to wait for it to log in here.
I've signed in. Should I start web also? Console of the web.
Yeah, you can start those up. The Web 2 and the database. They will need a bit of configuration before they're quite ready to go, but there's no problem there.
Okay, I've
Sorry,
started.
yeah. Mine is painfully slow here. But in the meantime, we can start discussing our architecture. So when we set a VLAN, if we go back actually to the presentation, we go here. we see the way they have this set up is this 10.0.2.0/24, this 10.0.3.0/24, 10.0.4.0/24. And what does that mean? So 10.0.2.0 is a basic IP address. It's just 4 8-bit numbers between 0 and 255. But the /24 is what's known as CIDR notation. Back when they first developed IPv4, they had these. They really underestimated how many things are going to be connected to the internet, and some of the ways they divided up, IP addresses didn't really make sense to us today because it made sense to them in the past. And one of the ways they did this was with classes. There was class A, class AA, and essentially that meant if you had a class A IP address range, the registering authority would give you an entire range of, say, 112.anything. 112.anything is entirely, you can assign it as, say, they'd give it to like the University of California, Berkeley. They'll say, you can assign anything, you have full control over assigning anything of like 102. whatever. And they call that A. Or there was, more levels. It might come down a little bit closer. They might say, hey, this specific field office of the DARPA, this government office for defense research, they can control all this 204.103.206, and then anything after that. All 255 spaces are theirs to do with as they please. And that idea is actually very useful, and it's like sort of how we build VLANs. At the time, it made more sense, but as we sort of started running out of IPv4 addresses and the whole class system breaks down a bit, we instead go to classless interdomain routing. And all that means is instead of trying to fit it into a specific class of how many IP addresses you have, they pretty much just count. This slash at the end represents how many bits are the unchanging ones and how many bits left are the ones you can change whatever you want. So there's 32 bits in an IPv4 address. So if this says 10.0.2.0/32, you can't change any of the 32 address bits. That's all it is. You only get one IP address. But if we say /31, well, now we can say you get to switch that last bits from a 0 to a 1 if you'd like. You get 2 IP addresses, so on and so forth. And so 10.0.2.0/24 is basically stating that VLAN 2 IT, and by the way, these aren't actually registered. None of these are going to be registered with an actual registering authority because we can just make them and like make it a private network. We aren't like sending, this isn't part of the greater internet. All of it comes through our gateways. That has an actual IP registered address from us. So it's given to us by our ISP, or maybe we've directly negotiated it with a governing authority. But in the building, we get the packet. It has the IP address to us, and then it has further clarifications on where exactly it wants to go. So we can sort of control that as we want. Now, in this case, so we've given all of IT in much the same way that the original governing authority gave, like the University of California, Berkeley, a whole bunch of IP addresses. We give them slightly less than a whole bunch. We'll give them 10.0.2. anything you want. Anything on 10.0.2.1.7.98. That's going to be IT related system structures, whatnot. 10.0.3. anything is going to be HR. 10.0.4. whatever is going to be sales. And so what we're going to do is we're going to do something similar for a private facing server, our public facing server, and our workstation. And so we go back here and Jesus, this is tough.
So basically /24 is like, you can say it's subnetting.
Yes, yeah, subnetting is generally a more general concept that you could include VLANs in. because it might also refer to a physical network segmentation, but it's literally the same concept.
Okay.
It's just specifically we virtualize the logic so that we can just run it all on the same hardware, keep it exactly as secure.
Right.
And I'm actually somewhat concerned about this pfSense box not letting me sign in on the web.
Oh, is it? No.
I'm wondering if it's just being slow.
I have used admin to sign in. I got into the machine. It's
Yeah,
visible.
no,
Let me look at your interfaces real quick. Your workstation. Yeah, no, that should be right.
terminal, IPA. IP is just a suite of tools to look at your own networking information. In this case, it tells us this is just a loopback address. This is basically the section of the computer that is dedicated to talking to itself. This is the one we're actually concerned about, not loopback, in this case, ENS18. That's just a very specific designation given to certain kinds of, specifically, if it knows it's in a virtual environment, and it's not like a real port, like a real Ethernet port or a real wireless connection card, wireless interface card. You might see auth0, eth0, any number of things here. But in this case, all of this looks good. 192.168.1.10. We'll use top to look at our resources. Sort of if you've used Windows Task Manager, and then checked out the resources tab to see if there's any bottlenecks. This is the same thing, but Linux. Nothing seems out of the ordinary. We can see the percentage of like CPU power and memory being taken up, but yeah, none of that seems abnormal. I think I'm going to factory reset the pfSense box, because why not? And you can see it's letting us know it is a successful login for the user. All right, that works. I just asked it to go into HTTP instead of HTTPS. It automatically went back to HTTPS, but we're in, so whatever. All right, so in order to set this up, let's just quickly design it. We'll give the private-facing servers, we'll give the public-facing servers 19, so sort of it's similar to what we already have. Let me exit out of that. IPA to show, sorry, let me boost this out. IPA to show our networking information, 192.168.1.10. So I don't know, public server, we'll give it .10. Whatever is in there. For the private servers, we'll do .2, .2. Whatever's in there, or .20, .10, .20, and then we'll do .30, whatever for the workstations. Easy enough. You could alter that if you'd like. It's part of your design. It's you, not me. But that's what I'm going to be doing here. So the first thing you're going to want to do, you're going to want to go to assignments. clicking on interfaces and going to assignments. This is going to be tough. It's going to be like this the whole time, isn't it? Well, at interfaces, you'll see what are known as network interfaces. These are going to be the actual circuitry that, if it were a physical computer, connects computer with the ability to communicate on a network.
Yeah, I got two of them. VLAN, VNet, VLAN and WAN and LAN. So
Yep, WAN and LAN. So the WAN, that's a stick on the router that's part of, sorry, there is an actual configuration for this known as router on a stick, which is very different. You're probably not going to see it. It's kind of a legacy technology, but it is used in testing and in very like specific situations with like, if you have two sorts of IP telephones systems that don't play nice with each other, you might just use a router on a stick. Regardless, the WAN is the part of the router that connects to the internet that allows us to actually get packets in and send them out to the rest of the wider net. The LAN is the local area. It's us. It's our part. So that's what we're going to be fiddling with once we're eventually in there. Maybe I can just go. No, I can't. Okay. All right. So I'm trying to delete these. Ignore these. You're going to have them in a moment. But first thing we're going to do is just go from interfaces to VLANs over here to actually make the VLANs. And this is, of course, going to take me 10 minutes. God damn. That's tough. But you should see an add button once you're there.
yeah, add section is popped up. So I should go in the add and need to configure it, I guess so.
Yeah. God damn. What is happening with this?
I got parent interface, VLAN tag, VLAN priority.
I guess Nick, while you're trying to get that one to work on your end, there's a David 2 user on one of the other on the 223 server. So if you want to just use that, go ahead and use that.
All right,
So
perfect. Thank you, David.
That's just a clean, so you can go ahead and use it.
All right. So workstation. Work. Make sure this is all booted into. Oh, look at that. It's so fast. It's already up. Perfect. 192.168.1.1. Open up Firefox. And we go to 192.168.1.1. First, let me just pop this out. And we log in, admin. Again, don't save, we remember. And it is a good bit faster, thank God. All right. Interfaces. Assignments. All right, and then we'll go over here. We see VLANs. We click on that. And we are going to add some VLANs. So first one we're going to add is we'll make it the public server. VLAN tag. This is just to identify which VLAN is which. We use 10 because I like decimals. One thing that's important here, the parent interface, because this is on our local area network, we want to make sure it's on the LAN network interface. So not VNet 0, which is on the wide area network, which is going to be on the other side of the router that we want. So we go to LAN, we tag it whatever you want, theoretically, a 10, and we'll give it a description, public facing servers. Simple, easy breezy, beautiful. You hit save. Let's add another. Once again, LAN. We'll do 20 for this LAN tag, and we'll do private network facing servers. Save. And let's add another because we're having so much fun. LAN again, because we're on the local area network. VLAN tag, we'll set it to 30. And this is just going to be for workstations. Now, all three of these exist sort of as an entity within pfSense. We actually want to like apply them to something. So you'll go back to interface assignments, and we're going to actually assign the VLAN to an interface, either the LAN or the WAN, which obviously, as this is all in the local area, it's going to be the LAN network for us. So,
Nick, quick question.
Yeah.
What would be the VLAN priority, or we should leave it blank? Because
the VLAN priority you can leave blank. It is something that you'd want to consider if you had enough VLANs and you were worried about collisions, essentially, where one server might be, one host might be trying to go for one of two VLANs and it's not sure which to connect to. We don't have to worry about that here, so you can just leave it blank. Doesn't matter.
So one is public facing servers, one is network facing servers, and another one is?
Yeah, so sorry, let me go back to the VLANs. I set the VLAN tag 10 to public facing servers. That's going to be our web server. I set VLAN tag 20 to our private facing servers. That's going to be our database. And VLAN tag 30 to our workstations. That's going to be this guy eventually. What we don't want to do is immediately throw this guy onto the workstation VLAN because it's by default, VLANs block all traffic, and then we won't be able to connect to the web interface, which is fun, but you can get around it, but it's kind of obnoxious in any capacity.
So why you select that interface as LAN one? Like, okay, because there are two interfaces, WAN and LAN.
Yeah. So this is the parent interface. This is basically which like actual piece of circuitry, or in this case, logical circuitry, because it's not a virtual machine, but what represents an actual physical port are we connecting to?
Okay.
Now we have these ports set up such that one is facing out to the wider internet. We can't assign a VLAN. We're not going to assign VLANs to the internet. That'd be a bit weird, especially for our current architecture. So we're just going with LAN, LAN, local area network, because this is all local to us. Local area network.
Understood.
VNet 1. So once you got 10, 20, 30 for public, private, and workstations,
Yes.
then we'll actually go to interface assignments and actually assign those to those ports. So it's fairly simple. You see available network ports and the actual VLAN we want on the LAN port here, the VNet 1 public facing servers. We'll add that. And it automatically moves to the next one. Beautiful. We'll add that. And the third one, we'll add that. Now, they've been added, but they aren't actually doing anything because, among other things, they haven't been enabled. So in order to manipulate the actual interface here and how it reacts with the VLAN, we'll just click opt1 for the 10th we made. First thing we click, enable interface, because we want this to work. We're going to give it a description better than what it currently was. So public facing servers.
So in the interface section, just a moment.
So if I were to go back to assignments, it just had the all the VLANs that weren't added. Just hit add and make sure it's on the VTnet 1 LAN.
Yeah.
And then you just hit the little interface name that it's been given.
Yeah. Enable it.
And then hit enable interface because we want this to actually work. For description, we'll throw something in there. Public facing servers. We want to be redundant with this because it's better to over communicate what this does, obviously, clearly, easily, than under communicate it. Now, what we're going to want here is IPv4 configuration type. This is basically asking us, how do we want to actually set up this network? Do we want hosts to ask us for what their address is going to be? Do we want to just assume they know what it is? And what we're going to do is going to be known as IPv4 static. So IPv6, that's basically, you'll remember, beginning of the lecture, they did not realize how many things were going to be connected to the internet, so they designed IPv4 with enough address spaces for 4 billion items, because they thought it was going to be like a million max. And now it's 6 billion and growing substantially. So one of the solutions to that is IPv6. You know, parts are moving very slowly, but you know, you see progress. Basically, it's a lot like IPv4, but it's a much larger address space, so that theoretically every single atom in the universe could have its own IP address and then some. So that will be fine. But we're not going to deal with that. It's long, it's complicated, it's hard to remember. So we're just going to use IPv4, and we're going to use static IPv4. These other ones, they require some setup that we're just not going to bother with because we only got 3 hosts. We can just tell them which hosts to use. So static IPv4. And we're actually going to have to assign a gateway here. And you can think about this as like the IP address for the VLAN's connection to the router. So because this is going to be the 192.168.10. whatever, I figure it makes sense 192.168.10, and we'll just give it .1, right?
It's 1921, Nicholas.
Now, whoops. That is not an IPv4 address. There we go. Thank you for catching that. I appreciate it. And then you'll see at the side here, this slash number. That's the CIDR notation. Once again, this number represents how many bits of the 32-bit number that makes up IPv4 are currently unchangeable. So this would mean our IP has only one address. We'll change that to 24. Yeah, math is hard. This basically means that anything from 192.168.10.1 to 192.168.10.255 is going to be considered part of this VLAN. That should be good. We'll hit save. And then we'll hit apply. It's weird. They have you do both. I don't know why specifically, but if you don't hit apply after hitting save, nothing is saved. It's a lie. Or maybe it isn't, and I'm just like missing some easy save feature that I could have used a while ago. Regardless.
We need to add gateway in the bottom. Is it required?
The IPv4 upstream gateway?
Yeah.
We don't need to add that. We need to add that essentially if we had a bit of a towering,
Okay.
you know, subnets in subnets, you'd almost want to say. And you know, you can see its second line here on local area network interfaces. The upstream gateway should be none. This is our local area. We don't need to go upstream. It's just local. So it's just us. Just good stuff. All right. In any case, change has been applied successfully. Perfect. That's our first. You can see, yeah, we got public facing servers here. Now we can again go back to interfaces, assignments, and click on opt2. You could also just click on opt2 from the menu. And this is going to be our private facing servers. We're going to do the same thing, but with .20 instead of .10. Enable. Give it a good description. Static IPv4. Give it a good IP address. 68.20.1. And we'll give it all of that last little number of the IP of the 4 like digit, not digits, but you know, octets. That's the word. That's the word. And then we'll hit save. And then we hit apply. And we'll wait for it to take effect. Perfect. All right. And now, look at that. Public facing, private facing. We know what they are. We don't have to guess. I love that. We'll go to op3 and we'll do the same thing, but for the workstations. Enable the interface, give it a good description, set it to static IPv4, and give it the IP address 192.168.30.1. Again, give it that last octet to play with. I remember one time, to share a story during this wonderful pause, during the CCDC, the Collegiate Cyber Defense Competition. At one point, we got locked out of our own firewall because the red team managed to get in. You know, the attackers who were there to break all our services. They managed to get into the firewall and block us from getting in. And so we just sort of team member in charge of the firewall gave it a good factory reset. And that we didn't know the default credentials to get into this router, so we couldn't get in. But then the red team also couldn't. And so while it wasn't a very good firewall, it actually worked and stopped, like, when the red team had access to it, they had set it to block like all traffic throughout the LAN. But factory reset, I mean, it was generally permissive. We don't necessarily want permissions in a cybersecurity competition, but it'll let our services run. And then you can just cover for it with host firewalls. So that's always nice. All right. So we now have these interfaces. They're running. They have things about them. Anything in the VLAN can communicate with anything else in the VLAN. Nothing that's not in the VLAN can communicate with things that aren't in the VLAN, unless we specify it specifically. How would we actually get the computers into the VLANs? Because we set it to static IP address, we're just going to have to change the computer's IP addresses manually. So in order, to get to it before that, I'd like to add in a couple of rules just to make sense. So we're going to click on firewall. We're going to click rules. And you'll see we have the WAN, the LAN, the public-facing service, private-facing service, and the workstations. Start with the workstations because this is the one we're on, and we will add the most permissive rules available. So by default, when there's no rules in the VLAN, it just says block everything into or out of the VLAN, other than like this is the VLAN. It's very restrictive by default. And it doesn't want to let anything in, right? So we're going to add some rules that essentially allow us, we'll just say you can communicate from anywhere to anywhere on the workstations. Keep them free, keep them usable for our hard workers and for us. So we're going to hit add, and you'll see two options, one add to the top of the list, one add to the bottom of the list. That's because the way this works, the rules will develop in a list. And any single piece of data that goes through there, it'll check it against that list one at a time from the top down until it finds something that matches. So if you have, say, block everything at the bottom, but you have like allow traffic from this one host to this other host, when that host tries to connect to that host, it's not going to get to the blocks, it's going to get to that first on top, that allow rule, and it's going to be able to get through. But everything else, it's going to skip that rule because it doesn't apply, and it does apply to everything blocks everything. So here it's going to be, our action is going to be set to pass, basically allow the yeah, sorry, my apologies. Coming off a bad cold here. We're going to allow the actual package of data to get through. The interface is workstation, so from the workstations, you can go anywhere. You can, ask where the router is, the source, any destination, any, and the protocol. Basically, internet traffic has a bunch of different hats, uniforms you can wear, different strategies. These are decided by big organizations, IEEE, and they're set as a standard for everyone else to follow. We can set that to any if you want. Literally have an insanely permissive, you can communicate outwards here.
Nick, a quick question.
Yeah.
Can you just navigate once to this section? I didn't follow you.
Absolutely. So we're on workstations. We'll add.
Okay.
Our action is pass. Our interface is workstations. This is about the workstation. This makes sense. So this is basically asking where the packet's coming from. They're originating. This is from us out. We're going to say any protocol at all, whether it's TCP, UDP, then ICMP ping packet, remote streaming packets, remote desktop, we don't care. We're very permissive here. The defaults are just going to be any and any. We're going to leave that. Anywhere to anywhere is going to be all right. We're going to hit save.
Okay.
We should have added a description, but I did not. My apologies. And we'll hit apply. Now, we might actually want to block rules allowing us to access the database from this machine, just because, private service. I mean, we work here, but I don't trust anyone here. So we'll do at the bottom there, or at the top, because remember, if this blocking rule is at the bottom, then any packet is going to get to this any to any rule first, and well, it's going to see it's going to pass the rule, and it's just going to head on. It's going to add at the top. It's going to be block. Workstations. Any. So from any source, and we can do private facing servers, network or address. Basically, address would be a specific address, and network is just a network in general. So right now, this firewall rule blocks any protocol from anywhere within the workstation's VLAN to the private facing server's VLAN. And you know what? We'll hit this log packets that are handled by this rule. That basically says whenever this tries to happen, we'll record it. Maybe it's a security incident. We should look into it. Maybe it's just a network going wrong. I don't know. Description, blocking filthy plebs from ruining the perfect database. Descriptive rules. And you'll see it's at the top. It'll be the first one there. So now if we have a workstation, we'll be able to ping, outside of the network onto the LAN network, onto the WAN network. We'll be all right. So we go to next, we'll go to the public-facing service because I think this is going to make the most sense. We're going to add a rule. And that rule is going to be a pass rule for anywhere else to basically be able to access HTTP, HTTPS requests from the servers. It's serving up a web page. That's what it does. So this is HTTP and HTTPS are going to be TCP, UDP for a specific port range. We're going to do 80 and 443. These are the default ports for these services. Ports basically just allow us to standardize how we deal with services and not have everyone have to manually configure every single web page connection. So, yeah.
Sorry to interrupt. Yeah, the first which we did, that allow root. So it was for workstations, right?
Yep.
And then next one was for private, where we need to select the protocol as any or the IPv.
The second one was actually also for the workstations.
Yeah, I did it, but the protocol is any, right? For that also?
Yes.
Same.
Yeah.
No.
I'll give you a minute to catch up here.
Yeah.
I need to refill my water anyways.
Yeah, sure.
Are you caught up, Shreyas? I'm sorry, I can't hear you. You're still muted.
You're telling to me? Or
Yeah.
Yeah, I'm there. I'm there. I'm here only. I was waiting for you.
Oh, all right. So for this firewall rule, we're going to just be taking, from the public-facing web server, we're going to be passing and we're specifically want to be using HTTP, HTTPS requests. These are specific to web servers, and it's the only thing we want our web server to provide. We don't want, anyone being able to remote desktop into our web server. That would be ridiculous. So we are going to source from anywhere. We don't really care. The destination, we're actually going to need to make two rules for this, one for HTTP, one for HTTPS. But you can see it makes it really easy. You can just select from, so for any port.
Okay, I'm on it actually. Okay.
So, we're passing from public-facing servers any TCP UDP protocol that is HTTP port 80. Designated to any port 80 device on the network. Because we only have one, so web servers. I know. We'll make the description allow HTTP. Let's save. And we're basically just going to copy that. And if you did not see what I did there, there's this little button here right in between the pencil and the disable. Just copy. And it pretty much copies it. But the one thing we can change, HTTP to HTTPS. And then we can hit the description, allow HTTPS. Save, perfect. That's what we want. One caveat. We also want this server to be able to communicate with our private-facing database server. So we are going to add a rule that allows us to send packets along a certain port range to the database servers and to the private-facing servers along this port 3307. That's specific to. I know that seems a bit arbitrary, and I apologize for that, but it's just the default port that the database service is going to use. So 3307. So we're going to pass source from anywhere on the public-facing servers network, because there's only one. We don't have to get fancy with it. To the private-facing servers network from the specific port of 3307.
Nick, you navigated to private servers, right?
No, we're still on the public network. This is a rule to allow us to send packets to the private network. We'll have to make another rule on the private network to actually accept those packets, but for now.
Okay. Actually, I was on another screen because of that.
That's all right.
Public pass.
Yep.
So protocol will be TCP UDP, right?
Yep, TCP UDP. Actually, thank you for catching that. I had it just set to TCP. Whoops.
Yeah, it will be TCP UDP.
Yep.
And you said custom port that is 3307, right?
Yep. And don't forget the source and the destination, because we want to be specific here. Only from public-facing servers to private-facing servers. This isn't some, we don't expect this server to be making this to some random YouTube video. It's specific. Public-facing servers to private-facing servers. This is what we allow.
Public and private. Okay.
And then we hit save.
Nick, for previous to HTTP and HTTPS, I have not set any invert match for the source and destination. So
yeah. So do you have these asterisks here?
A moment. Yeah, I have that asterisk. Yeah.
Yeah, that's basically a wildcard. It stands for any. That means that it doesn't matter what the source or the address is. This rule will apply to any source, any destination, which is what we want. We don't really care. We're serving up HTTP. We're getting HTTP requests. We don't care who, what, where from. We could get fancy with it, but this is a tutorial. There's not really necessarily a point there. So now we go to private facing servers. All right, sorry, first, of course, I almost forget. Hit apply. It's been applied successfully.
On it.
Did we? Oh, yeah, we did. We did.
Done.
Did we? We did not apply it. Damn. We're gonna hit apply. God damn it. What? No, never mind. My apologies. It is, we're good. Now we go to our private facing servers. We're gonna make one rule. There is a request from the public servers along port 3307 to one of our servers. We'll let that through and vice versa. So we'll add the ports that will pass. Because again, the default is just block any. It's probably good practice to note that explicitly, but for now, just in the interest of time, we'll keep it simple. So we will pass protocol, any. If the source is a public-facing net and the destination is a private-facing network, sorry, TCP UDP, my apologies. And it is along 3307, we'll allow it. So once again, we are passing, the private-facing servers will pass any packet that is TCP UDP port 3307 coming from the public-facing servers to a private-facing server. We'll allow that. We'll hit save. And then we'll add another one for the reverse.
So here also we are selecting TCP UDP, right?
Yep.
Okay.
Now, if there's anything from the private service network that wants to communicate with the public-facing service.
Public-facing.
Yeah, perfect. So,
private to public.
accept.
Private to public. Okay. Done. Save. Private to public, public to private. Okay.
And we'll hit save. Now there is one rule we are missing. That is the final part of this, asking the database where something is. That is public-facing service. We don't know what to do with it once they actually give us a return. We actually have to explicitly allow the database to respond. So we'll add. Shit, we still need to apply. Whoops, we'll do that later.
Nick, quick question. You have added 2 rules in private section, private facing servers?
Yep.
Oh,
first,
no. I messed up.
Yeah, we got the source from the public-facing servers, the private-facing servers along 3307, and the reverse. We also allow the private-facing servers to send packets to public-facing servers as long as they're along port 3307.
Oh, no. By mistake, I've added that thing in public-facing servers.
Yeah, whoops.
In public-facing servers, there are only 2, no? That is 443 and 80. That's it.
There's 443, 80, and we need to explicitly allow the public-facing servers to communicate along 3307 TCP UDP from public service to private service, and then the private service to the public service. So we basically got a copy of what we have on the private service here, also on the public service.
I messed up.
So it's actually not that bad if you already have both of them on the public service, because you need them on there anyways.
Public. Private. public to private and private to public in private facing servers. Done.
So public's allowed to communicate to private along port 3307, and privates are allowed to communicate to public along port 3307. Hit apply, both along public and on the private side.
Oh, I need to add that in the public side. Just one left.
Yeah, of course.
Add pass TCP UDP. Private facing server destination and the public. Private to public, public to private, 44380. I need to apply changes. And I haven't given the description. Okay. Allows responses from DB queries. Done.
You good to go, Trace?
Yep.
Perfect. All right. Now the only step that's left, well, 1.5 steps, getting the actual machines onto these VLANs, which is just going to be done by changing their static IP addresses, because we chose static IP. Makes it easy. But unfortunately, it's different for each distribution, and I chose 3 different distributions. That wasn't intentional, but it is, a reality of if you're using Linux, you're probably not going to be using the same one. So to start with a Debian machine, Debian's actually fairly, excuse me, straightforward. We'll log into it again. Web and web is the password.
With you. Debian 11.
And in order to get into the terminal in Debian's environment here, you'll hit activities on 9 boxes down the bottom here.
Where it is.
Damn, they really had it. Yeah, just search for it. Terminal.
But it is. Oh no.
And you've opened up the terminal. Good stuff.
Just a moment. Yeah, in Debian terminal is opened up. Yeah.
Perfect. All right. So Debian, you have to change a configuration file. If memory serves me correctly here. I'm going to check with it using cat/etc. Files will change, but not that often. Say networking. Network.
Did see that. Okay.
Interfaces. Yes, that's right. So.
No, wait. What
all right. First of all, SU space. We are transferring to the root user because we don't actually have privilege to change the IP address of the web server as a standard user. You have to have some privilege to it. So SU space, the password is going to be web because we kept it the same.
It's saying cat etc no such file directory.
When you cat/etc/network/interfaces.
Yeah, done.
Are you sure you don't have a
it's popping
typo
up a bit late.
There you go. All right, now we'll use a text editor to change that. Nano is my personal go-to. There's also Vim, VI, I think Notepad's on this thing. Whatever you want.
Yeah.
Nano's definitely the typical. We're gonna do
cat etc.
/etc, and instead of typing in all these words, I'm gonna hit tab to autocomplete. network. I don't want to finish that. Autocomplete. It autocompletes as best it can, but there's a bunch of things that end and start with net and end in a bunch of different things. There's networks, net interface, whatever the hell. We'll continue a little more. Hit tab. Perfect. Slash. And then interfaces. We just hit that. Brings us here. Basically, got to make a new network interface. It's going to be this auto LO. That's loopback. What is it? I actually don't know. Give me a moment. IPA to get the information about the networking. ENS 18 is the one we care about. All right. So, auto ENS 18. The interface ENS 18 on the internet is going to be a statically assigned IP address. And it will have the address 192.168. And we got to put it on the public facing VLAN. So we got to put it on one of those. And we gave it all 20, 192.168. Something whatever the hell. I don't remember which VLAN that is. I'm going to check.
Zoom interface is quite nasty.
All right. Yeah. Yeah. Public facing is 10. Okay. So we go to web 2. We'll do 10 dot whatever. I'll choose 10.100 because 100% is a good grade. We're also going to want to put a gateway here. That's going to be the address we set for the VLAN. Basically, just telling it, already asked questions. If you have questions about the network, if your computer, the computer will ask this IP address. And that was 192.168.10.1. You'll remember that's how I said it. I don't know how you specifically said it. It's fairly simple. Check. You just go back to the workstation. You go back to the assignment. You click on it. IPv4 address 10.1. Perfect. Okay. We save by hitting Control and S at the same time. Wrote 13 lines. Wonderful. Control X to exit. Now, if we do IPA, it's still going to show us the same IP address we had. Oh, disgusting. We need to restart our networking services. You're going to use System Control, System CTL. It's a tool that just lets you restart certain services in Linux. It's sort of like a command line version of Task Manager that lets you stop and end certain processes in Windows. So, System CTL, restart. So we want to restart it. Network.
Nick, sorry to interrupt.
Yeah.
I couldn't follow you till it was like too fast.
What parts are you currently at?
I am just editing the net interface.
Yeah, this one?
Yep, I guess so. Oh, just a moment.
Yeah.
Yeah.
So ENS 18 is us explaining to the computer that it does have this interface. We believe in it. It's an internet interface, or sorry, it's a networking interface. It's statically assigned. The address is what we put there. 192.168.10.100. It could be anything that's on the VLAN. As long as it's on the VLAN. And anything that's on the VLAN, it's going to be what we set at 192.168.10.1/24 if we're using CIDR notation, which is to say anywhere from that .1 to .255, as long as the preceding 3 bits, the 3 octets are 192, 168, and 10. You don't have to do it by octets, by the way. You can get really screwy with it, but it's hard to read as a human, so people typically don't do that. There's actually nothing stopping you from doing it. If you want to have like /11 networks or /7, if you do your entirety of networking in prime, like prime CIDR notation, I feel like that would be both very impressive and also very ugly. But that's neither here nor there. Just let me know once you're good with this.
Yeah, we can continue.
Okay, perfect. Control S, Control X. And then you're going to use that system control utility. System CTL restart networking.
Restart networking.
Yep. It should just go through. And now when we do IPA, you will see.
It's not taking restart networking. Networking dot service you should add or something.
What's the error it's giving you?
So it's telling if I'm using systemctl restart networking, so it is telling that error code system status networking dot service or something else you can use, but not systemctl.
Would you mind sharing? Would you be able to share your screen?
Can you just tell the command what you said? Systemctl restart networking.
Yeah, got that.
Oh yeah, you're using it in web. My bad. I was using it.
Oh
in
yeah,
web.
yeah. This is on the Debian machine.
You're
Were you
using it on
making-
Debian, right?
Yep. Sorry, what was that?
Restart. Okay. The heck. Never do- This is Debian web. Can I share my screen once?
Absolutely.
Okay. You cannot start
Stop sharing.
Where is to web? Hope you can see.
Says you have started screen sharing, but I think you still need to select a screen specifically.
Oh, okay. My bad.
There we go. Interesting.
Is it visible now?
Sort of. It's looking a bit weird. There we go. All right.
So it's showing me like this. Systemctl restart networking failed.
So my guess is there might be something wrong in the network interfaces file. So if you mind opening that up, just because I've run into this error 100 times fucking up interface files.
Oh, goodness. Where is that? Workstation.
It was the one that you were already in.
Yeah, yeah. It's not going to be on work.
Yeah.
Would you mind going back to the web server?
Yeah.
No, to the web machine.
Web.
The Debian
Okay.
machine.
Okay. Yeah.
Just nano/x/network/interfaces. You can
Mhm.
actually just hit the up arrow twice.
Yeah.
Yeah. Those shortcuts make it so easy.
Yeah.
Auto ENS. Okay, I see the issue. Auto ENS 18. You have a space between ENS and 18.
Oh, okay. There should be no space.
Yep.
Okay, my bad.
We during our competition, we had one of our services down for like an hour or two because someone accidentally put an O instead of a 0. So
Can understand. Yeah, it's working now.
All right, perfect. Now if you do IPA.
Yeah, okay. IP. Oh, my bad. Sorry.
Yeah, good.
IP.
And now you'll see at second line down there there's 192.168.10.100. Ain't that beautiful? Ain't that beautiful?
Yeah.
All right. Now, if you mind letting me share the screen back again once more.
Yeah, sure. I'll just stop my screen sharing. Stop share. Okay. You're good to go.
Perfect. All right. So now that I'm here, can I ping arbitrary? So ping is a command that just sends some ICMP echo packet. Basically, it's just used to test if a host is up or not. It sends this echo request and the host gets it and just sends back the same thing, literally. I found a great YouTube video called Harder Drives that discusses terrible storage methods. One of them, you just keep sending like pings around the world, and you can include a little payload because it's just copied back to you. You'll get it all eventually, and then once you get it, you just send it back out again. So, stored in transport. But ping 8.8.8, 8.8.8.8 is a specific server. It's a public-facing Google server. Google runs this one server. It's a DNS server, domain name service. It lets websites have names instead of just IP addresses. And you'll see it ain't connecting to shit. Destination host unreachable. How about to the pfSense gateway, to the pfSense box? Ping 192.168. What was it? 1.1. Still able to connect there. All right. Let's go to the database. Now, this is on something called OpenSUSE. It's still Linux. It's definitely a weird one, though. So we're going to log in, database. Excuse me. Database. And it's going to be in, let me boot all this out because it is a long ass time. First of all, we're going to do IPA. God. IPA. You're going to see ETH0. Again, LO, the first one, that's the loopback. We don't worry about that. The second one is the first real one. It's ETH0 in this case, instead of ENS18. So we need to go on OpenSUSE instead of on the Debian head, because they all got to be different. And once again, just elevate here. The password is, again, database. We kept it all the same. And we are going to ls/. We're just going to open it up straight in text editor using nano / etc. Files have changed, but not that often. System configuration, which is just sysconfig. Store system configurations. It's pretty straightforward. Network for network specific ones. And then this is, I don't really know how to motivate this. Just double hit tab to see the possible options. And you'll see IFCFG- something. And those somethings are always one of our interfaces. So either our loopback or our ETH0 in this case. You'll notice one of them has a .back file extension. That just means .backup. We don't have to worry about that one. It's a copy of the original to make sure that nothing happens. So /if cfg-eth0. Okay, and this one, it's a little weird, but it's honestly fairly straightforward. I'm just going to change the IP address to, what was the IP? The private IP subnet, was it .20 or .30? It was .20, right? Yeah. Do .20, and just to keep things simple, we'll do it .100. Leave this net mask alone, and the gateway, it's going to be 1.20.1. And you'll also change that route to default. Actually, no, you won't. Control S.
Hello, Nick.
Yeah.
Can you just show once the navigation? Like,
Yeah, of course. Yeah, it's sorry, I went
that?
there a little fast. It's /etc, files have changed, not that often, sysconfig, system configuration, network, about the network, and then this weird ass file name. It's going to be ifcfg-e0.
Okay, 1 minute. Okay, nano HC.
Etsy. That's what I'm speaking about. So I always call it etc. I don't know why. Well, actually, I do know why, because it looks like etc. But everyone looks at me funny.
Where is the command? You just typed the command, right? I was able to see it. I'm unable to see it. What the heck? A moment. Just a moment. Now I'm able to see. Let's see.
So just let us know once you're ready.
Yeah, just a moment. Sorry if I'm a little slow with this
You're
stuff.
fine. You're fine.
I'm doing it for the first time. That's
Hey man, you gotta throw yourself into it. Learn by doing.
yeah. But I'm unable to when I opened that.
Yeah.
Oh, where it went? Crap. Well, mhm. The changes you made were in where it is in database, right?
Yep.
Oh no, I just closed that. What is happening with me?
Share your screen. Let's find out.
No, I'm not. Uh-oh. My machine is like going to time. Hope you can see my screen.
Yep, we can see it.
Error.
Yeah. So the issue is you're currently not elevated. You're just as database user.
Okay.
Exit out of that. Real simple, real easy fix. Control X.
Just a moment. This is okay. Yeah.
And then SU space. Nope. Stop.
Oh, SU space nano.
Enter. Nope.
Oh, okay.
Enter.
Okay.
Then type in the password for the root user, which is database.
Oh, yeah. Now I got it.
Yeah, you don't normally have permission to read and write those files in OpenSUSE,
Yeah.
which I don't know if I'm pronouncing that correctly. I'm going to put the name of that in chat.
Just
OpenSUSE. SUSE. Thanks, David. You have space in there. See,
should not be there. There should be not. Oh,
there
is
you go.
it? Yeah.
There you go. So you change that IP address to 192.168.20.100, let's say. Or you can put it anywhere else in the .20 subnet, but whatever, or VLAN.
And this will be like 20.1, right?
Yep, exactly.
And no need to change anything. That is
And then just hit,
static auto 20.100 and 20.1, right?
yep, just hit Control S, Control X, or
Control-
right out, also fix.
Control X.
Well done, well done. All right, and if you mind letting me take back the screen
Yeah, sure.
for the final bit. And then we'll go into the workstation in Ubuntu, which is annoying-ish. They have a service that lets you change the IP address, makes it a little more easier. Work is work. I just gotta remember what it is. So open up the terminal. Let me expand my screen here. Open up the terminal.
Open terminal in pfSense, right?
No, in the workstation. Work.
Yeah. Oh, sorry, my bad. I saw the your configuration because of that. Yeah, I am on it.
Christ, what's the service? There's basically a service. You define give it a little config file, and it'll automatically change the IP address real easy. Screw it. I'll just look it up. Net plan. That's it. All right. I remember now. It's coming back to me. So we're gonna use as super user. We're gonna go to /Etsy/netplan. And then you're just gonna hit tab twice or not. Hold on.
Hey Nick, just a heads up here. We're approaching in on 2 hours here pretty soon here. So if you want, maybe wrap up pretty soon here, or
Yeah. My apologies here.
no, you're good. Yeah, we were in the zone there for a bit, so I get it.
There we go. So nano/@/netplan/01 network manager all/.yaml. It's weird as hell. Again, I'm really not sure how to motivate that, but it's just how Ubuntu does it. Sometimes you gotta look that up. So you'll open that up, and it's again real easy. We're gonna change this 1 to a 30, and this 1 to a 30 to put it on our VLAN we want it on. All right. Control S. Damn it. I don't have permission, do I? Sudo nano/act. There we go.
Yeah, we need to use sudo compulsory.
Yep.
I did the same mistake what you did.
Happens to all of us.
But I can open the
Yeah,
it is
you can read to this file, but you can't write to it. Linux
yeah,
file permissions get very specific and
yeah,
fine-grained.
privileges.
Yeah.
Sudo nano description.
So Control X. And
Sudo nano.
just restart the machine.
So what are the changes you made? I was like behind.
Addresses 192.168.30.100 and 192.168.30.10 to put it on VLAN 3 for workstations.
For the subnet mask, should it be 24?
Yes. Yes, it should. Although technically, it wouldn't necessarily matter, but it should.
Gateways 192.168.1. The only change is the address, nothing else.
Yep.
Control O.
And then restart.
Okay. Restart. Restarting it.
All right. And we'll open up the terminal. In Ubuntu, it's really nice. You can just right click on the background, open in terminal. And we hit them with IPA. We'll again notice 168.30.100. Sweet. Let's try and ping the private servers that we're explicitly not allowed to do. 192.168.20.100. And the thing is, destination host unreachable. But we can still ping 192.168.1.1. That's also concerned.
It's not reachable, right?
Yeah, not reachable there, but should still be able to hit it.
20. Is it 20.100 or 30.100? You have pinged 20.100. Oh, okay. Yeah, my bad. Sorry. I was checking on different stuff. 30.1. Two packets transmitted. Okay, 30.100. My bad.
But that is the basics of setting up using firewalls and VLANs. I did want to go through a bit of a demo with the website, but
Yeah, we can have one more session with. It is interesting. We can have another session for this.
yeah, absolutely. I'll try and get something together, record it, send it out, basically just showing the what we built works. But yeah, other than that, VLANs, firewalls, important, relevant, useful
Yes.
for security, efficiency, and we can use them separate to make more sensible policies.
Nicholas, just a request, if possible, could you, like you have designed a PPT, could you just add few more slides to it so that we, if we would like to practice it, so few commands and like to proceed it. So if possible, you can post it in the CyberHawks Discord, so that will be good. if
Yeah,
possible.
absolutely. Absolutely.
Yeah.
Well, anything else?
Yeah,
No?
it was David, like the last session was about DHCP server, right? Which Nick took. Yeah, I guess so.